Lesson 14.15, our last one in this unit, integrals of absolute value functions. So we're trying to find the area under absolute value curves, or I should say straight lines, because absolute value functions always make a V shape. Number one, start out with an easy one, which is the parent function. This is on a poster up on my wall, but I want to talk about the parent so that then we can speed it up and do things with transformations of the parent. So if I were to graph the function f of x equals absolute value of x, it has a point at the origin, 0, 0, because when I plug in x is 0, y is 0. If I plug in 1, y gets 1. If I plug in 2 for x, absolute value of 2 is 2. So it has this slope of up 1, right 1, up 1, right 1. Well, if I plug in negative 1 here, the absolute value of negative 1 is going to get y is also positive 1. So it has this symmetry. If I plug in negative 2, absolute value of that puts me at positive. So this is my function. Then it just depends on my bounds. They want me to go from negative 3 to 2. So if I were to think about this being here, this point is at negative 3 up 3. So I can find actually the area of this triangle. Then I could also find from 0 to 2 this triangle, because this point is at 2, 2. So it's always that number, comma, the absolute value of itself. Okay, so then this area would be, I've got a base of 3 and a height of 3. So I'd have 1/2 3 times 3 plus this triangle would be 1/2 times 2 times 2. So that would be half of 9 plus half of 4. That would be 2, and that would be 9/2. If I were to make that equivalent, that would be 4/2. That would be 13/2 would be my total area. All right, number 2, it will help knowing the transformation rules. So this time, instead of just having absolute value of x, I've got an x plus 1 inside. When you have a function, let's say f of x equals, and its absolute value, you have what's called an a value out in front. Then you have an x minus h, absolute value, plus k. We'll never see, I don't think, the plus k. But the number inside of here is a left/right movement. If it's x plus 1, then actually it went left 1. It's always the opposite of how it looks, because it's x minus the number, saying actually a negative 1 got plugged in here. Then the 2, that's a vertical stretch or compression. I'll just put stretch, vertical stretch. So actually this went 2 times higher than what it normally was. So if I were to graph this, I could do it pretty quick, because I know the parent normally has the vertex at 0, 0, but now I'm going to go left 1. And it doesn't go up or down anything because it doesn't have a k on the end. And so then the next point, I know that it's going to go up 2, right 1, and up 2, left 1. This is like the slope. What might be easier, though, is to just plug these numbers in. So if x were negative 2 plus 1 is negative 1, but the absolute value of that is going to be 1, and 2 times 1 is 2. So at negative 2, I'm going to be up 2. So that puts me there, and that's going to give me my triangle that I need to find the area of. And then the next one is if I plug in 1, well, 1 plus 1 is 2. Absolute value is 2 times 2 is 4. So 1, I'm going to have a point all the way at 4. I did not leave myself enough room for this, but that's the area I'm trying to find. Okay, so from there, it's seeing that this is a distance of 1. This is a height of 2. So I'll have 1/2 times 1 times 2, which is going to be half of 2, which is 1. And this one's going to be from, it's negative 1 to 1. That's a distance of 2 units up 4 units. So half of 8, which is 4. So it'll be a total area of 5. All right, the next thing we need to talk about is, what if we have absolute value in a rational function where it's got a fraction? Let's make a table real quick. Let's just do from -2 to 2, and you'll see what's happening. If I'm going to plug in -2 here, I'm going to take the absolute value of it, it's going to become 2, divided by still -2 would get me -1. If I plug in -1, that's going to become 1, but still divided by -1 is -1. If I plug in 0, I can't do, it's undefined there, because I can't divide by 0. If I plug in 1, that's just going to be 1 divided by 1, and 2 divided by 2. So anything that's negative is going to have a height of -1. It's going to look like this. So -2, -1. If I were to plug in -3, it's going to get -1, -4, -1, -5, -1, -1, -1. But 0 is going to have a hole. So this piece is horizontal to here. It actually makes a piecewise function. Then I would have a point at 1, 1, 2, 1. If I plugged in 3 divided by 3 is 1, 4 divided by 4 is 1, but it's going to have a hole here at 0, 1. So it creates a piecewise function. If you know that, then you can do these other ones kind of in your head. And I think that's going to be the fastest. So now we're going to try to make a graph and find the area of a curve, or under the function. We're given 3 times x minus 1. Well, that means this went right 1, and this means it went stretched up 3. So if I'm going to sketch a graph of this, I want to move to the right 1. So that's where my break, my open circles are going to happen. Instead of being at 0, now it's going to be here and here. But I also know that now it's going to be at 3 and -3. And so this one's going to go to the right. This piece is going to go to the left. They want me to find from -2 to 2. So I'm trying to find the area here and the area here. So it's just rectangles that I'm going to add together. So this would be 1 times a height of 3 plus this one is 1, 2, 3 units long times 3 units high. So that would be 3 plus 9 would be 10 as the area. Delta Math will show you that they make it a piecewise function, but I think it's way more confusing like that, honestly. I'd rather just sketch the picture and then think about it. Okay, and then number 4. This time absolute value is in the denominator. It's not going to change the graph. The thing that's going to change is that this is like a 1/2 here. So now instead of going up to where it's 3 and -3, now it's only going to go up to 1/2 and -1/2. And it's going to go left 2 since it's x plus a number. So our graph, our break would be happening at -2. So this is going to be 1/2 and -1/2. So -2 up 1/2 and -2 down 1/2. This is going to go to the right. This is going to go to the left. They want to go from -3 to 0. So this piece and this piece. Okay, so every time our heights are going to be 1/2. So I've got 1/2 times 1. Oh, I just now know what I forgot to do. I'll fix it here in a minute. 1/2 times 1 and 1/2 times 2. I forgot to make the part below the x-axis negative. So this actually should be a negative. So it'd be -1/2 plus 1/2 of 2 is 1. 1 minus 1/2 would be 1/2. There's your area. Go back to number 3 real quick. This part here, The 3 by 3 should have been a -9, so actually that makes your area be -6 when it's netted.